Hi, everyone. I'm glad to be here today. My name is Clément Nussbaumer. I come from Switzerland. I'm a Swiss software engineer working at PostFinance. And fun fact, I live on a farm with my wife. She's a farmer with her family. And so I get to see cows every day, and then I get to play with Kubernetes during the day as well. So I'm a lucky guy. So let's get started with this session about our migration from Kubeadm, I'm not sure how you pronounce that, I will use Kubeadm, and towards ClusterAPI+Talos. So how old can your clusters get? Our oldest clusters will soon turn 6 years old. And today, it is now 2,099 days old, which gives you the title for this session, actually. Why do we bother with keeping clusters alive for so long? Why don't we always recreate new clusters and move applications there? For us, the choice is due to the way we work with our clusters. We use quite large shared clusters on which there are lots of namespaces for lots of application developer teams. So instead of moving 500 application teams to new clusters every time there's a new release, we prefer to just update and upgrade the clusters in place. And up until now, we've been quite successful with that with Kubeadm so far. PostFinance. PostFinance is a small bank, or small. It's a bank in Switzerland. We run 35 vanilla Kubernetes clusters, so the open source distribution. We just use Kubeadm to configure everything and run the multiple components of Kubernetes. As I said, the oldest cluster will soon turn 6 years old. We run all of that on 2 on-prem data centers. We do vSphere virtualization, and then we create the virtual machines that we need for our nodes. We run Chaos Monkey on all clusters. This might be a fun fact, but it's really helpful for us because up to the production clusters where we run the card payment services, we run Chaos Monkey. And this helps us a lot when we have to do an upgrade because the application have to be able to withstand a pod restart. So that's a little about what we do at PostFinance and with Kubernetes and cloud-native technologies. That being said, let me explain how we currently provision our clusters, the starting point. So for now, we provision Debian VMs with Terraform. When we boot those VMs on our on-prem clouds on vSphere, then we run a series of Puppet configuration. I'm not sure how many of you know Puppet. But let's say I'm looking forward to working only with Talos. So we use that, and then we have to manually register those nodes in an inventory.yaml file that we use to run the Ansible playbook. And then we run this Ansible playbook, and what it does, it basically renders the config files, so the kubeadm config files, the kube-apiserver manifest. It calls kubeadm commands to generate all those manifests so that the control plane can actually start. And then, finally, one of the last stages is to configure ArgoCD integration because we deploy everything with ArgoCD, or almost everything, including our own workloads, also infrastructure workloads. Like we use ApplicationSets for that. We deploy Nginx or Cilium with ArgoCD. So that's what we do today. The last part, ArgoCD, we are happy with, but the first 4 steps, we are not so happy. And so that's why we want to move to ClusterAPI. And I'm not sure how many of you are currently using ClusterAPI. OK, so I would say 5%. That's not much, but you might be using it without knowing it. But so ClusterAPI in a few words. ClusterAPI, the idea is that you use the declarative APIs of Kubernetes to provision and to make your cluster work. So you have a management clusters on which you create the CRDs for ClusterAPI. And on this management cluster, you have a series of controllers which will monitor the CRDs that you need to instantiate the ClusterAPI cluster. And the clusters that you create with ClusterAPI, they are called workload cluster. So here, this example is just for lab clusters in this drawing. So we have here one management cluster which manages 3 workload clusters. But I have another drawing right afterwards which might explain that a little better. On the right side, you can see that ClusterAPI, you can interact with it as you would with any Kubernetes CRD or resource. You can use kubectl for that. You can get machine deployments, which is the deployment for your worker nodes. You can get machines, which will then, through the controllers, we instantiated as either a VM or an infrastructure or any resource. And that will, in the end, be your nodes. So that's about ClusterAPI in a nutshell. Then Talos Linux. How many users of Talos Linux in the room? It's growing, that's good. I can only recommend. It's referred to as the 12 binaries OS. It's immutable, minimal, ephemeral, but for us, the main point is that it has a declarative configuration interface. So you don't interact with it with SSH because there is no SSH on Talos Linux. Instead, you authenticate with MTLS to an API server running on the operating system, which is called machine D, which does most of the configuration. And so you use the Talos Scuttle command line tool or directly you could also use API requests to configure the operating system. So you will configure the network card, the storage. You will configure everything with this declarative API. And for us, that's a game changer. We can go from deploying Debian VMs and configuring some tools with it with Puppet and then running Ansible pipelines to just using a declarative API to configure the operating system. That's about it for Talos. And now, how do we migrate from this kind of old Ansible Kubeadm way of doing things to Talos and ClusterAPI? So the first step that we have to go through is configuration matching. As we can imagine, some parameters between Kubeadm and Ansible might not be the same. Sorry, Kubeadm and Talos ClusterAPI might not be exactly the same. So we have to match that. The second step is that we need to import all the existing PKI infrastructure, so all the existing certificates from our existing clusters. We need to import those so that we can work with those in ClusterAPI and Talos. Next, we have to go to the ClusterAPI management cluster, and there we will start to create the CRDs that are needed to create new machines, new nodes to join the existing cluster. The third step is to add ClusterAPI nodes, and this will not go right the first time that you try to do it, but I will give you a few headers on what not to do and how to interpret the error that you might encounter along the way. And finally, when everything goes well, you can remove the Kubeadm nodes and you have a ClusterAPI, and it could be any other operating system, but you have a ClusterAPI cluster at the end. So we are not there yet. Everything is ready technically, but we are in the process of migrating, and hopefully in a few weeks or months we'll be able to publish a blog post about it and how it went. So let's start with the configuration matching. I will not go into too many details, but the main things to watch for are to match the service account issuer. That's the name of the service account. That's the name of the issuer that you get if you dive in a pod and you check the George token that is in /var run secrets, etc. You will see an issuer field, and this issuer per default is kubernetes.default.services/cluster-local. And with Talos, this is not the case. With Talos, they default to the endpoints of the cluster. So you have to match that on the old Kubeadm cluster. You have to already do this small change, but you can do that without downtime. That's fine. And then this one is really important. You need to make sure that the etcd encryption key and the key name are the same between Talos and Kubeadm. And so on the right-hand side, you have the Talos template file, so the file that they use to actually create the encryption config file on your Talos machine, Talos system. And you see how they template it, and mainly you see the name line 11 or line 17, depending on which etcd encryption scheme you use, ASCBC or secret box. You see which name your key needs to have on your Kubeadm old cluster. And so you have to match that, which means that you have to basically re-encrypt all secrets, but this is quite a simple operation, as we can see on the third step, and it's all explained really in super detailed in the Kubernetes documentation. So that's for the first step, or the step 0, the preparation step. Then we have to import the existing PKI. And here, Talos is quite helpful. They have a command called kubectl gen secrets from Kubernetes PKI. So you can give this Talos Scuttle command line tool the path to the existing Kubernetes PKI folder in which there are all those CA certificates, etcd certificates, service account issuer, key, etc. And it will generate a secrets bundle file that you can use later on to either provision a new cluster without ClusterAPI, or that we will use just afterwards to actually provision the new ClusterAPI cluster. You also need to create a new Kubeadm bootstrap token or Kubernetes bootstrap token so that new nodes can join the existing cluster. So that's for the first step. So importing the existing PKI, and that is how the secrets bundle look like. So we have the bootstrap token, the secret box encryption secret, and then the key, the core Kubernetes certificates that constitute a cluster. So the Kubernetes cert, line 10, 11, the HCD cert, 7 and 8, the service account, and finally line 15 and 16. This is not something that is from Kubernetes itself, it's from Talos. It's the OS key, so operating system in this case, it's Talos. And so this key, line 15 and 16, the OS key is the certificate that you use to authenticate against the Talos endpoint, so the Talos API. So you don't use an SSH key, you use a certificate, and if that certificate has the OS admin group, then you're allowed to do some operations on the Talos nodes with the Talos scuttle command. So that's it for importing the existing PKI. And now we have to create some ClusterAPI CRDs. I'm not sure if you can read well in the bottom, but I will soon switch to a drawing because this is a little indigest. But the main point is that you have a cluster CRD, you have a control plane CRD, and maybe it's simpler to read it like that. So that's how we structure our clusters. So we create one namespace per workload cluster. So here the workload cluster is called E1 Kubernetes Lab F. And so we have a cluster CRD, so that's the one that you see on the left-hand side. And then we have a control plane CRD, the one in yellow. Another one is the machine deployment. Then you have also an infrastructure, but you could have multiple infrastructure providers. It's up to you. And so all the CRDs are there, and nothing happens so far. But then the ClusterAPI controllers, they start to interact with those CRDs to provision the nodes, the machines, to boot the VMs, if it is VMs, to boot the bare metal boxes, if it's bare metal boxes with metal cubed, whatever. And so that's how ClusterAPI works. So you have to create those CRDs, and then the controllers start to provision machines. And it can go extremely quick. So now we know how all of this works, how we want to do the migration. The last step for the migration is that we are going to add ClusterAPI nodes to our existing clusters. So on the left-hand side in blue, you have the Kubeadm nodes. We have more nodes than that, but for the drawing it was much simpler like that. And in green on the right-hand side, we start to add ClusterAPI and Talos node. And that's actually how we are going to do the migration. We have the existing clusters with perhaps 100 nodes, and then we'll start to incrementally add new Talos nodes to the cluster, and we'll monitor closely because it's certain that there will be some edge cases like some fine-tuned sysctl parameters that will break some Java deployments somewhere. It's almost sure. So we'll have to monitor closely over the course of several weeks to see which of those parameters we have to fix. But basically the idea is that we have the old cluster, we start new nodes in the sense with ClusterAPI. We wait a little, and in the end, the idea is to completely replace the old Kubeadm nodes, and we will have then successfully migrated without downtime all our clusters in a few months if everything goes well. So that's the idea. So when you create ClusterAPI nodes, a few things can go wrong. I've summarized it here. We've encountered that along the road. For example, if you do not match the service account issuer, then the new service account token that you create, they will not have the proper service account issuer, so it will not be accepted by the old API servers. Then in the authentication logs, you see that you have invalid bearer token errors. You could lack the HCD encryption key. If you do not have it, that's how the error message looks like. You could have the wrong HCD encryption key, and this is a little more tricky because you would expect, well, maybe another failure, or an error message which is more verbose than output array was not large enough for encryption, but that's what you get if you don't have the right HCD encryption key. And finally, when you start adding HCD nodes to the cluster, if at some point you have some nodes which are down and you lose quorum, then you have to use the force new cluster flag to recover your HCD cluster. Perhaps you already have had to do that. So let's get to the demo. Let's hope the demo gods are with me. So let me explain a little. So these here are the manifests that we have in our that we'll provision for the lab F cluster. So that's the one those are the manifests I showed you before. By the way, is it big enough at the bottom? Well, I don't hear anything, so looks good. I see thumbs up. Thanks. So this is the manifest that we use for. This is the cluster manifest. Basically, the cluster name, then the endpoint for the cluster, then you have to refer the control plane, and then the infrastructure. Then you have the control plane itself. And here you see we use vSphere machine template, we use Talos 194. This is like the image template on vSphere itself. And one important thing here, we start without any replicas, and I will get to that in an instant when we start the migration. But basically, the thing is that if you create those CRDs on the ClusterAPI clusters, and you already start one replica, you first have to. I will show you. It's going to be easier when I show it. Okay, so this is the control plane CRD, and then we have a customization file here, which generates secrets and generates all the CRDs that we need to start creating these workload cluster nodes. So I think that's it. Then I have a few workspaces here. The second workspace, so I'm switching to it now, the Talos Scuttle workspace. We will use that one to retrieve the logs of the Talos operating system when it boots. Then the seventh workspace here is one of the control plane of the old Kubeadm cluster. So you want Kubernetes MLSU 010. We will start a watch on the etcd Scuttle member list here, because if everything goes well, we should, when we start the CRDs and when we increase the number of replica, we should get a new etcd member in this workspace here. Then on the eighth workspace, we have the ClusterAPI management cluster. So for now, we don't have a lab F cluster. We'll soon have that, and we'll go inside this cluster and see which CRDs are created. And finally, the next tab is the lab F nodes tab. So it's just an overview with K9s of the running nodes on that cluster for the moment. So we have 6 nodes at the moment, hopefully a 7th one or even more if we have a little more time. So let's get started. Perhaps, so the file structure is this one, the one we see on the left-hand side. So the first step that we have to do, we have to actually import the existing PKI. So for that, we use this script here. So I will run this script with SSH on the target control plane node, so on the existing control plane node. So we will generate the Kubeadm join token. We generate the Talos secrets bundle, the command that I showed before. Then we'll generate, or we will read the etcd encryption key, substitute that with a little YQ command, and print the file out. We'll directly print the file out and save it to the secrets folder, secrets bundle file. So to do that, we SSH on the node, and we pipe the scripts, and that's it. So now in the secrets bundle file here, we already have a first step. We have the secrets bundle file, which corresponds to our actual Kubernetes existing Kubeadm clusters. So with the right Kubernetes certificates, etcd certificates, and everything. So the first step is done. Now we also need to create some TLS files. So I have created a small script for that as well. It just reads the CRT and key file from these lines here, and it saves that here. So just some YQ commands. So let's review again the CRDs. So here we have the control plane, 0 replicas. This is important. Data plane, 0 replicas. And I think with that, we should be able to apply this customization on the ClusterAPI cluster. So no error so far. The demo god seem to be with me for now. So we have a new namespace, KAPI 1 Kubernetes PFnet Lab F. KAPI is standing for ClusterAPI. When we get into this namespace, we don't see any pods because we are not working with pods here. If we check the clusters CRD, we see that we have a CRD. So we have a cluster, ClusterAPI cluster instance. And then we could check for machines, but normally there shouldn't be any machines because we haven't increased the replica count yet. We can also check for Talos control plane, and this is an important resource. This one is the one that will be used by the controller. The Talos Bootstrap provider will use this instance to create the Bootstrap data, which is the data that it needs to send to Talos when it initializes the node. So those are the CRDs that we currently have on the cluster. And now the next step that we need to do, I will run this here. It's not really important where we run it. We need to patch this Talos control plane. This is the critical bit. If you don't do that, if you don't patch it with the bootstrapped equals true flag in the status sub-resource, if you don't do that, then when you increase the replica count, Talos or the controllers of ClusterAPI will believe that it is a new cluster, completely new cluster. So they will send a bootstrap command, and then this new node will not join the existing one. It will just form a new Kubernetes cluster on its own. So it will not join etcd, and then you just lose some time. But if you run this command here, if you patch the existing Talos control plane, then its status of bootstrapped becomes true. And here we should be seeing that in the status. Bootstrapped is true. And now that I've done that, we can start our first control plane replica. So let's do that. We could also directly edit the resource, but it doesn't matter. So I apply this with one more replica. So now we see we have one replica. And if we check the machines, we should be having a new machine, which is provisioning. Good, so it has been provisioning for 13 seconds. We don't have an etcd member so far. It should come in around 40 seconds, hopefully. We might be able to check the Talos scuttle logs. I have already prepared the IP address. I first need to create a Talos config file. It's always a step that I forget. You need a Talos config file to actually interact with the node. This should be the one, and we should be able to watch the logs of the node. So we see on the Talos node is booting, and we see that the etcd service is waiting to be up. Let's check the old control plane node on the 7th workspace. We don't have it yet. It should soon come up and be alive. Normally it's after 1 minute, so I think we can wait a little more. And here we have it. So our new ClusterAPI node, which has just booted Talos, just joined the existing etcd cluster. This is a good first step. And now that this is done, the kube-apiserver on that control plane node will also be able to communicate with etcd, will be able to start. And kubelet on this new node will be able to reach that kube-apiserver and register itself in the existing cluster. So now if we go back to the nins tab where we have the nodes, and if we wait a little more, for how long have we been waiting so far? Not sure. So almost 2 minutes, so it should soon come up. And so now the nice part is that I could simply increase the number of replica, and then there will be a new machine starting instantly. And I could do the same for the machine deployments. Machine deployments is what you use to provision worker nodes or data plane nodes, as we call those. So the suspense is increasing. Let's check the Talos scuttle. So it's not yet happy about the kubelet endpoints and TLS internal error. This is normal because we haven't signed the serving certificate yet. But if I continue talking, normally the node should appear. So before we continue, in the description of the talk, I had also mentioned some ArgoCD ApplicationSets part. I will not be covering that because I don't think we have enough time and it goes into too many details. I should prepare that for another talk at some point. But I put those slides at the end of the slide deck. You have some of the templates that we use, and it can be quite helpful in managing the workload clusters. And so, yeah, here we have our new node, which has joined the existing lab F Kubeadm cluster. We see Cilium, which is starting. And yeah, in a few seconds, we should have all nodes with the ready status, which means that we will have actually migrated, or then we have done the first step towards migrating. There is still some work to be done to complete the migration, but the first step, at least, it's done. We have a node a control plane node which we integrated with the existing Kubeadm control plane. So it's not worth waiting for another minute that it comes ready. Maybe I can switch back to this one later. So that was for the live migration. Now, the bootstrapping issue, the chicken and egg problem. So we want to manage our clusters with Kubernetes cluster. But how do we do when they're in a disaster recovery scenario? If we lose everything, if we don't have any clusters, how do we manage our workload clusters without a management cluster API cluster? And so the idea that we had is to use an ephemeral tool, or we have written a small Go utility that we might open source at some point. And what this utility does, it starts a kind cluster locally. It installs all the cluster API CRDs and controller on the cluster, and then it checks on an S3 endpoint whether we have already existing manifests for an existing cluster or not. And if those manifests are there, it just re-imports those, and then it can manage the cluster. And if those manifests are not there yet, what it does, it will just provision a new management cluster. So only for the management cluster, we use this ephemeral tool to actually manage the management cluster itself. That's the solution that we found. We run that in a GitLab pipeline, but we could also run that on our laptop if we needed. We just need to collect all secrets and have the right network access. But then we could really provision a cluster from scratch in a disaster recovery scenario. So that's it that's our solution to the bootstrapping issue. So in conclusion, we have seen how to match configuration, import the existing PKI, add new nodes. We saw what could go wrong on the way. And the last step that we'll be able to conduct in a few months will be to remove the Kubeadm nodes. So yeah, I think that's it for this session. I will end up with a few words in patois. Patois is the old dialect from the French-speaking part of Switzerland, and it means take care. So poche vopi. Thanks. So if there are any questions, I'm happy to take questions right now or after the session, as you like. I don't see any question, so I guess that's it. Thanks.